Earlier we discussed that all congruent triangles have to have congruent angles as well as congruent sides. That turns into us needing 6 congruent factors to check each time. So we would have to check that all of these 3 sides are congruent to these 3 sides, as well as the angles are all 3 congruent. But we have some little shortcuts here. So the first thing we're going to look at is the proving of triangles congruency using the side, side, side property. And we usually denote this as SSS, just as a shorthand writing of the side, side, side congruence postulate. And all this says is if you have 3 sides that are congruent to 3 other sides on a triangle, then you can say this triangle is a congruent triangle. So here we have that side AB is congruent, as denoted by this tick mark here, to side DE. We also have that side BC is congruent to side EF. And then the last side, AC, is congruent to DF. So what we can say is by side, 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 congruency postulate, triangle ABC is congruent to, again, making sure that the vertices do line up. This is congruent to triangle DEF. Let's put this to work. Side, side, side would mean that here we have 2 triangles. All sides need to be the same. Notice this interior line here, it's shared by both triangles, so that side is automatically the same. We have 26 is the same as 26, 2 sides of the triangle, but here 13 and 15 do not equal. So we cannot use side, side, side here, and these 2 figures in particular are not congruent, just by looking at them. Now the second figure, we have 2 congruent sides here, marked by the tick marks, 2 congruent sides here, and then the shared side in between the 2 triangles is also congruent because it's shared by both of them. So we can say that by side, 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 these 2 triangles are congruent. Let's now turn to formalize different ideas in a 2-column proof with both the statement and reasons. First thing we always have to do is come up with our givens. And reading the problem, it says that line segment PQ is congruent to QS. So the first thing I would do is indicate those congruencies on the picture just to let myself know while I'm trying to work through this. Also, we have that PR is congruent to SR. So we have PR and SR. Make sure that you use 2 tick marks on that one since we've already indicated the congruency of the other 2 with 1 tick mark. And we want to prove that these 2 triangles are congruent triangles. So step 1 of the proof is to state our given. Our end goal in sight should be that our last line of this proof is that these 2 triangles are congruent. So have that in mind, that down here our end game is right here. So we have to figure out some way to say this. For step 2, we have that line segment QR is congruent to itself. And that's just by the reflexive property. By saying this, now we have 3 line segments or 3 sides of the triangle that are congruent. So what we can say is the triangles are congruent. 3 congruent sides, side, 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 lets us say that that is a congruent pair of triangles. In this figure, we have that side TU is congruent to WX, that's in the given, and TV is congruent to VX. So I'm going to put 2 dash marks. The third piece of information is that V is the midpoint of line segment WU. Remember, what a midpoint does is it splits the line segment in two equal or two congruent segments. So what we can say is that WV is congruent to VU. Now, what I've basically just said is the formal proof. We have three congruent sides of two different triangles, so we kind of know ahead of time that, well, what we're trying to prove, that these two angles are congruent, or these two triangles rather are congruent, that's going to happen by side, side, side. We have to formally justify this in statements below, though. Step 1, we have to state our given. So I've written it down there, and the reason is, well, that's the given. Step 2, we had previously that two of the segments were congruent. We had to prove the third. And what we came up with was that WV, line segment WV, was congruent to line segment VU. And that, we said, was by the definition of midpoint. The fact that it does split this in half, this line segment in half. Lastly is our proven statement. We have the three congruent sides, so we can actually say that triangle TUV is congruent to triangle XWV, and this is by the side, side, side. So now you just have to be aware that whenever using side, 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 if you can come up with three congruent segments, you're good to go, and that's all that's necessary.